Hi friends, how are you doing? Over the last couple of days we've been doing multiple videos on motion, the physics topic, and today I want to teach you the concept called slope. But before we do that, those videos which are there in our Instagram handle, okay, you please go ahead and have a look at them. Only then you will be able to appreciate this particular lesson. All right. So this concept called slope is very important for us to solve the numericals that we get in the distance time graph and the velocity time graphs. And I want to explain this to you using a very simple example, right? So what we have is a ladder out here propped against a wall, and maybe you want to remove a book from a shelf. So the ladder is somewhere in the middle of the wall, it's not propped to the top. So this particular distance is what we call as the rise, and the foot of the ladder is away from the wall, and this distance between the foot of the ladder and the wall is what we call as the run. Okay, so if you look at the example B, this foot is moved closer to the wall. Okay, therefore you see that the rise is much higher here. Maybe you want to fix a tube light or something at the top of the wall, and this run, because the ladder is quite close, the run is small. Okay, so if I were to ask you friends, which ladder will be easy for you to climb? Okay, intuitively you will say ladder A is going to be easy because it is less steep, right? So this steepness which you are talking, as you would have guessed, is related to slope. So slope is nothing but a measure of this steepness, right? So how do we actually put a number around this, right? So if you look at it, this rise and run have a role to play. This steepness or a slope is a measure of the rise over the run. So if you look at the first case, this rise is smaller when compared to this, of course, and the run is large. Rise is coming in the numerator, so small value divided by larger value. Therefore, as you would guess, this slope in the case of A is going to be small. Whereas in the second case, slope in example B, this rise is a larger value. Okay, so you have a larger value in the numerator and you have a smaller value in the denominator. As you would guess, this value of slope will be larger in comparison to the case A, right? So that's what is slope, is a measure of rise over run, ratio of rise over run. The second thing you would have seen and guessed is this angle has got a very important part to play, right? So if you have a smaller slope, this angle is small. So small angles, this is also called the angle of inclination. Okay, the smaller angles are associated with a small slope, and if you see here, this angle is larger when compared to that. So larger angles are associated with larger slope. So friends, I hope you have understood the concept of slope. Now let's try to do some numericals. Alright, so we have seen that slope is equal to rise over run, right? So let's take some generic graph, okay? We have something x on the x-axis and something y on the y-axis, right? Let's consider a line AB, and this point A has coordinates x1, y1, okay? So this is our x1 and this is our y1, and this point B has coordinates x2, y2. So from the origin to this point is x2 and this is y2, okay? So we have to express this slope, which is the rise over run, in terms of these coordinates. How do we do that? Let's do this. First you have to connect this, and let's call this as ABC, okay? Now can you guess what our rise is going to be? If you say BC, then you are right, okay? So this BC is going to be our rise, and this line segment AC is going to be our run. Okay, so we need to compute rise over run now in terms of x2, x1, x2 and y1 by 2. Okay, so if you look at this distance BC, right, this is nothing but this from here to here. How do we get this? This whole thing we know is y2 and this is y1. So what is this going to be? This is going to be y2 minus y1, right? So this distance, which is the rise, is going to be y2 minus y1, and likewise this run, you would have guessed it, is going to be x2 minus x1. Okay, so whenever we say slope and we have a straight line with coordinates, you can now say slope is nothing but the difference in the y coordinates divided by the difference in the x coordinates between the 2 points. So we have now defined slope as the difference in the y coordinates by the difference in the x coordinates between the 2 points. Okay, so now I will take a distance time graph, right? So in the distance time graph here, distance is in the y axis, and let's say the distance is specified in meters, and we have taken time on the x axis, time is in seconds, right? So we have to calculate the slope. What would slope now be? Okay, so slope is now going to be the difference in the y coordinates, so s2 minus s1 divided by the difference in the x coordinates. The x coordinates now happen to be t2 minus t1. Okay, so s2 minus s1 by t2 minus t1 is going to be the slope. But what is this slope going to signify in the distance time graph, right? So if you look at it, this is the distance traveled by maybe some object which is under observation between the time intervals t1 to t2, isn't it? So what was the distance traveled between the time intervals is s2 minus s1. Therefore, this is the distance traveled. And what is the t2 minus t1? T2 minus t1 is the time interval. And what is the physical entity which is distance by time? Distance by time is nothing but speed, right? Therefore, slope has got a meaning in the context of a distance time graph. Okay, in the context of a distance time graph, the slope is going to, if you calculate the slope, it is going to give you the speed. All right, now let's look at a different graph. Supposing instead of distance time graph, okay, we take a velocity time graph. Okay, so here in the y-axis we will have the velocity. Velocity will be, let's say, meters per second, and in the x-axis we will have time, so there is no problem here. So coordinates of A will be t1, v1, and B will be t2 and v2, right? So what would the slope signify in the case of a velocity time graph, right? So let's put what slope is. Slope is once again the difference in the y coordinates, which is nothing but v2 minus v1, divided by the difference in x coordinate, which is nothing but t2 minus t1, right? So v2 minus v1 is change in velocity, isn't it? So this is change in velocity over time, and yes, most of you have got it right. Change in velocity over time is nothing but acceleration. Okay, so the concept of the slope is the same. The way we are computing the slope is the same, but slope means different things in different context. In the context of a velocity time graph, slope is going to give you acceleration. In the context of a distance time graph or a displacement time graph, slope is going to give you either speed or velocity. I hope you guys have understood this. We'll do a couple of numericals around this slope. Bye. guys, we also use online platform called Guru for making courses, content, and we have a lot of assessments. And these assessments are of various levels of difficulty, like L2, L3, L4. And there are a bunch of questions which, if you do on a consistent basis, will really improve your knowledge and help you to remember. Okay, so if you can register for these assessments by clicking this link, and we will call you and we will enable you with a login ID on this platform. And trust me guys, that regularly if you practice, it's really going to help you a lot.